A warm welcome to all of you joining us for our live coverage of the Sentinel 6B launch. We're now less than 60 minutes from the planned liftoff from Vandenberg Space Force Base in California. We have a nice surprise for you this evening. As this is a NASA launch, we already have views of the pad. At this point in the countdown, the engineering teams should have completed their pre-launch reviews and made a recommendation on proceeding with the launch. We'll talk a little more about the countdown shortly. I'm Stephen Young, and I'll be providing our commentary today. We're broadcasting from the Spaceflight Now News Bureau at NASA's Kennedy Space Center. Will Robinson-Smith is taking a well-deserved vacation, so I will be at the commentary mic tonight. I am joined running the technical side of the broadcast by John Pisani. As this is a West Coast launch, the rest of our team has the evening off. Although weather was a concern for tonight's launch, it does appear that conditions are not as poor as had been forecast by the meteorologists at the Space Launch Delta 30 weather team based at Vandenberg Space Force Base. They had predicted yesterday that there would be a 60% chance that the poor weather that has been affecting the West Coast over the weekend would risk violating some of the launch criteria, with cumulus clouds being of particular concern. But it does appear that conditions are fairly clear at Vandenberg currently. Looking at the GOES West satellite imagery, we can see that there are some clouds streaming off the Pacific towards the coast of California, specifically the Vandenberg area. But it does appear that it is not as bad as had been feared. So weather, I'm sure, will remain a watch item. So we'll stay tuned for any updates from NASA and the launch team on that. For those of you asking in the chat, the trajectory tonight is generally southeasterly. With this particular payload heading into a very specific orbit to allow it to take measurements over 95% of the ice-free oceans of the world. And we are hearing that the range is reporting that there are no vessels in the downrange area. Range should be giving their go for the continuation of the countdown, their range ready call. So just to return to the trajectory briefly, and we can see the NASA weather briefing taking place. Sentinel 6B is heading to an orbit with an inclination of 66 degrees. It'll be a circular orbit, about 830 miles high. That's 1,336 kilometers. The precise launch time tonight is 9:21:42 seconds Pacific Standard Time. The window is just a 20-second window that opens at 9:21:32 seconds. And currently, NASA is targeting the middle of that window for tonight's launch. So we're just hearing that the launch weather officer is confirming that conditions are indeed improved, and there is a 90% chance of acceptable conditions for launch this evening. Before we take a look at the countdown, just like to give a big thank you to our moderator in the chat, Jeff Hansen. Please help him out by following the rules of the chat. Also, you can help us by hitting the like button and clicking subscribe and the bell icon so that you never miss any of our live streams. If you'd like to do more, we'd very much appreciate it if you consider making a donation through the Super Chat feature or by becoming a member of our YouTube channel. Membership grants you access to our special members-only videos as well as discounts in our online shop. A huge thank you to everyone who made a contribution to help fund our coverage. So let's take a look at the countdown timeline. The launch director is about to perform a go-no-go poll. We're actually seeing inside the Mission Directors Center, which is the NASA control room at Vandenberg Space Force Base. So the poll will start shortly. NASA's conducting its own poll, and then SpaceX will conduct a poll of its launch team. The Launch Control Center for SpaceX at Vandenberg is located about 11 miles north of the Launchpad. Today's launch will also be supported by teams at SpaceX's facility in Hawthorne, California. If the go is given to proceed with the countdown, that will start with the loading of propellants aboard the first and second stages, starting with kerosene on both stages and liquid oxygen on the first stage. With 30 minutes left on the clock, cryogenic helium load will start. The helium is loaded into carbon fiber pressure vessels located inside the rocket's liquid oxygen tanks. This helium is used to pressurize the rocket's tanks as the propellants are consumed, and that keeps liquid oxygen and kerosene flowing to the Merlin rocket engines at the bottom of the rocket. The loading of helium starts with the first stage and continues with the second stage 4 minutes later. Loading of kerosene aboard the second stage, which is the smallest propellant tank on the Falcon 9, should wrap up around the T-minus 23-minute mark. Meanwhile, loading of kerosene into the
all stations, this is the NLM on the NLM net. Momentarily, I'll be conducting the propellant and launch readiness poll. Just to give a summary of where we are this evening, I will recap. We had good collision avoidance report and made our entire 20-second launch window available, so we have adjusted the T0 to the preferred time of 05:21:42 UTC, and we are tracking towards that. Earlier in the countdown, we did have vessels in the payload fairing recovery ellipse. They are now deemed not a concern for launch, so we are no longer tracking that. Weather continues to be a watch item, but it's been trending favorably. Our probability of violation in weather is now down to 10% for thick clouds and cumulus clouds. And so, therefore, we've got a good spacecraft, got a good range, mostly good weather, and a great rocket. So let's conduct this poll and see if we can go put some propellant on board. I'd now like to conduct the propellant and launch readiness poll of the NASA team, beginning with NASA CE.
NASA CE, go.
Copy that, NASA CE. SMA.
SMA is go.
Copy SMA. SMD.
SMD is go.
Copy SMD. NASA MEM.
NASA MEM is go.
Copy NASA MEM. LSP.
LSP is go.
Copy LSP. NLM copies the NASA team is go for propellant load and launch of Sentinel 6B. NLM out.
That was Tim Dunn, the NASA launch director for this mission. Let's return quickly to the countdown chart now before we reach the point where SpaceX will give their go for the start of propellant load. So following the conclusion of kerosene load, the next major event in the countdown is the start of the strong-back chill-down process. The strong-back structure sits alongside the rocket on the launch pad. You can see it in the box on the right-hand side. It's the truss-like structure that sits up alongside the rocket. In addition to providing support to the vehicle, it serves as the conduit for propellant lines,
This is the
air
LD
conditioning.
on countdown 1, performed a clear to launch poll. NLM, are you clear to proceed to the launch auto sequence?
LD, this is NLM. We are go for propellant loading.
Copy that. LDA, is the range ready to proceed?
This is LDA. We are clear to launch.
Copy.
So the remainder of the SpaceX poll is actually conducted electronically.
The LD on countdown 1, the propellant loading poll is complete and we are go for propellant loading. For non-urgent no-go conditions, brief the CE or LD and they will approve aborting the countdown. For urgent issues affecting the safety of the operation, operators shall call hold on the countdown net. Launch control will abort the launch auto sequence immediately and proceed to the launch abort auto sequence. At T-minus 10 seconds, launch control will be hands-off and relying on automated abort criteria for the remainder of the count.
So with that, the SpaceX launch director has also given his go for the propellant load sequence to begin. Resuming our run through the countdown, we reach the point where the strong-back chill-down process begins at the T-minus 20-minute and 50-second mark. This actually becomes visible a few seconds later by a large cloud of vapor created as the liquid oxygen lines are cooled. That cooling process is preparing for the next major step in the countdown, which comes at the T-minus 60-minute mark when it's the turn of liquid oxygen to start flowing through those strong-back lines into the second stage. At T-minus 7 minutes, the chill down of the 9 Merlin first stage engines will get underway. A small amount of liquid oxygen is flowed through the plumbing and turbo pumps. As the name suggests, this cools down the engines to protect them from thermal shock and damage when the propellants start flowing during the startup sequence. About 6 minutes prior to launch, the first stage kerosene tank should be full. Then at T-minus 4.5 minutes, we'll see the strongback start to retract from the Falcon 9. Prior to this, the pressure will be increased in the propellant tanks to strengthen the structure of the rocket, as it will no longer have the physical support that's provided by that strongback. The strongback of Vandenberg is a little different from the ones that you might be used to at Cape Canaveral and Kennedy Space Center. It will recline to an angle of about 13 degrees and remain there through launch. About 3 minutes before liftoff, the first stage liquid oxygen tank should be full. Then around 2 minutes before
Falcon 9
launch,
things are venting for propellant load.
2 minutes before launch, liquid oxygen loading should be complete on the second stage. At that point, the Falcon 9 will be fully loaded with 1 million pounds of propellants. In the final 60 seconds of the countdown, the control of the final sequence of events will be handed over from the ground sequencer to the Falcon 9's onboard flight computers. The propellant tanks will be brought up to flight pressure, and if everything is looking good, the SpaceX launch director will give their final go for liftoff. We're just seeing in the box on the right-hand side of you inside the payload fairing, showing the Sentinel 6B spacecraft mounted atop the payload adapter. And you can see the inside of that fairing, which is appears to be a brand new payload fairing. The two halves were placed around the satellite. We actually have some video of that we'll show you shortly. Just to complete the countdown timeline, at T-minus 3 minutes, 3 seconds, sorry, the engine ignition command will be issued. And then at T0, the 9 Merlin 1D engines at the base of the Falcon 9 will reach full thrust. The flight computer will command the hold-down clamps to release the Falcon 9 for a liftoff at 9:21 p.m. Pacific Daylight Time.
The launch auto sequence has started.
And there we have confirmation that the propellant load sequence is now underway. This is an automated sequence and begins with the loading of liquid oxygen on the first stage and kerosene on both the first and second stages. We'll start to see some frost and vapor building up around the first stage of the Falcon 9. This booster 1097, is flying for the third time. This is also a milestone for SpaceX in that it is the 500th flight of a previously flown Falcon 9 booster. Until this past week, SpaceX was the only company to successfully recover and refly an Orbital class rocket. But Blue Origin joined the club by at least recovering a booster. They still have to prove they can refly it. But they taken that first step in reusability for their New Glenn rocket. So nestled in the payload fairings at the top of the Falcon 9 rocket is the Sentinel 6B satellite. It's the second in a series of 2 satellites that are part of a billion-dollar international project to monitor rising sea levels in near real time around the world. NASA has produced a video that gives the highlights of this spacecraft's mission. So let's go ahead and run that now.
Really exciting high-tech satellite mission where we're measuring the height of the ocean from space. If we think about shipping, national security, fisheries, all of these depend on this information.
The ocean is very dynamic. It changes all the time. Having a measurement really is important towards understanding what's happening with the ocean, both in real time, but also in terms of forecasting.
We're in the business of trying to avoid emergencies, not just respond to them after the fact.
Sentinel-6 is a unique project. So it consists of 2 satellites built as twins. And the first one was launched, Sentinel-6 Mike Freilich, in 2020. The second one was built in parallel. We literally have hundreds, if not thousands of people working to build these programs together.
So Sentinel-6 Michael Freilich has been looking at the Earth sea level around the globe, and now Sentinel-6B is going to take over. We've been tracking changes to sea level using satellites since 1992, so it's been more than 30 years now.
The way that Sentinel-6B measures is it sends a radar signal down to the surface of the ocean and measures how long it takes that signal to get back to the satellite. And from that, we can really get a very accurate measurement of how sea levels are changing locally and on a global scale, down to about a 1-inch accuracy.
Very dangerous Hurricane Milton rapidly approaching the west coast of the Florida Peninsula with multiple life-threatening hazards.
In 2024, Hurricane Milton intensified very rapidly, and Sentinel-6 Michael Freilich data were able to help us forecast this intensification.
Better predictions allow people to get out of the way before the storm hits. It allows them to take measures to protect their homes and their businesses. It allows emergency crews time to set up. All of these things are going to save lives.
That's the goal, is really to have data that's available within hours of the observations.
Sea level measurements are really critical to a number of different industries. So if you think about the packages that show up at your home, the expectation is that they arrive on time and arrive quickly. And Sentinel-6B can provide us the information we need to understand how to move things as quickly as possible from one part of the Earth to the other. So from a national security perspective, the U.S. military has installations all across the globe in coastal areas. Understanding the change in water level is really critical to preparedness.
With fishing, that data is used to understand where the fish are, how healthy they are, how they can be sustained, and how they can be managed better.
Sentinel-6B carries on this legacy of measuring sea level in a very consistent and very accurate manner.
Sentinel-6B will really propel us into the next decade and continue that sustained, highly accurate observation.
And understanding how water is moving in the open ocean, how it's moving close to the coast, that's really important information for us to protect our way of life.
So thank you to NASA's Jet Propulsion Laboratory for putting together that package explaining a lot of what this mission is about. So always a lot of questions about trajectory for these Falcon 9 launches. So let's take a look and see where this Falcon 9 is flying as it leaves the pad. This is a satellite image of Space Launch Complex 4 East, or SLIC 4E for short. The pad has been in use since the 1960s. It was first used to launch Atlas and then later Titan rockets for the U.S. military. SpaceX took over the pad in 2011 and converted it for Falcon 9 launches. If you look over to the left-hand side of the left-hand box, you'll see a circle that is the landing zone 4, that will be used by this Falcon 9 rocket when it returns to the launch site. The satellite image here captures the strongback structure lying down at the pad, and in the top portion of the box you can see the hangar where the SpaceX Falcon 9s are processed prior to rolling out to the pad. So zooming out from Vandenberg and spinning around, looking to the south and out over the Pacific Ocean, can see where Vandenberg is located on that point. And this particular mission will be taking a southeasterly trajectory at approximately 2 minutes and 20 seconds into flight. The first stage of the Falcon 9 will separate, and it will perform a flip maneuver and a boost-back burn that will return it to Vandenberg, landing at landing zone 4. And that pad, if you want a sense of scale, is about 1,400 feet west of the actual launch pad where the rocket will take off from. So we're looking into the European Space Operations Center at Darmstadt, Germany, where the satellite will be controlled after it separates from the Falcon 9 vehicle. This control room has been used for a lot of historic missions, including the Rosetta Comet landing. We're back in the Mission Directors Center, NASA's facility at Vandenberg. So although the Falcon 9 will return to the launch site, the fairings will continue downrange and parachute on steerable parafoils into the Pacific Ocean, where they will be picked up by a SpaceX recovery vessel. SpaceX saves about $6 million every time it reuses these fairings. The fairings tonight certainly look like they are brand new. They feature the logo for the Sentinel 6B mission. We have a file photo of a fairing recovery operation taking place. This particular photo was taken in the Atlantic Ocean after a launch from Cape Canaveral. And we're hearing that the spacecraft has switched to its internal power. The helium is being loaded on both the first and second stages. Certainly starting to see the buildup of vapor. It's a useful fuel gauge to see exactly how much liquid oxygen has been loaded aboard the Falcon 9 by the time the process is complete. That thrust
Stage
line
2 RP1 load is complete.
Will reach the top of the vehicle, and we just heard the call that the loading of RP1 is complete on the second stage. And there we see the start of the so-called big vent, the chill down of the liquid oxygen lines ahead of the loading of liquid oxygen into the second stage. Loading of kerosene and liquid oxygen has been continuing into the first stage of the vehicle. This chill down process will last for another couple of minutes, and the loading of liquid oxygen onto the second stage will get underway at the T-minus 16-minute mark.
Stage 2 LOX load has started.
We just heard the call that the loading of liquid oxygen aboard the second stage is about to get underway. So appropriately for a satellite that is going to monitor ocean height levels, this particular satellite was not flown to the launch site, but it was shipped from Europe, from the Airbus factory where it was manufactured in Germany, to Galveston in Texas, where it was offloaded and then trucked to Vandenberg, traveling across the country from Texas to California. See it here arriving at a NASA facility at Vandenberg. Inside its specially built container, shipping container that is air conditioned, and this is the opening of that container inside the Astrotech facility. Delicate operation to lift the lid on the box without damaging the spacecraft. And here we see it on its support stand that it was shipped on. The solar panels on either side of the spacecraft. The gold is the thermal insulation that helps maintain the correct temperature for all the onboard electronics. And speaking of the spacecraft, here's a live view of Sentinel-6B inside the payload fairing of the Falcon 9. You can see the solar panels in this view inside the payload fairing. Those are obviously crucial for any spacecraft to ensure you have the power you need to do the work required of the scientific instruments. There were some testing of those panels conducted inside the Astrotech facility at Vandenberg prior to the spacecraft being encapsulated. Here we can see technicians getting ready for a test of the panels. There are 2 fixed panels and 2 panels that swing open. And a standard test for most spacecraft is to ensure that those solar panels will deploy. These are much smaller than some of the solar arrays that it can extend many dozens of feet on either side of a spacecraft. You see the first panel deployed and now the second panel. So that was a successful test of that solar panel deployment. The next major event was the encapsulation of the spacecraft within the payload fairing. This also took place in the Astrotech facility at Vandenberg. The satellite was lowered onto the payload adapter, the black cone-like structure at the bottom of the image here.
on internal power.
With the spacecraft installed on the payload adapter, the two halves of the payload fairing are then moved into position. Last time that human eyes will see the satellite, though obviously we are getting those camera views from inside. Always a big moment for any team preparing a spacecraft for flight. You can see those new payload fairings. They're supported by the blue structure till they're bolted safely together. There's the Sentinel-6B logo on the side of one half of the fairing. And there's the completed fairing mated together. We're now less than 10 minutes from the launch of this Falcon 9 rocket. This is a relatively young Falcon 9 booster. Let's take a look at the flight history. Booster 1097 made its debut in September on the Starlink 17-8 mission. It performed another Starlink delivery run, carrying the Starlink 11-29 mission to low Earth orbit. And then we reach today, the flight of Sentinel-6B. It's flown pretty much every month since it's been introduced into the SpaceX fleet, with a turnaround time of 30 days between its first and second mission, and 45 days before of preparation before this particular flight. Coming up on the engine chill.
Engine chill.
There's the call confirming the start of engine chill, the flow of a small amount of liquid oxygen into the Merlin 1D engines at the base of the Falcon 9. You may see a little wisps of vapor as that process is conducted. That ensures that once the propellants start flowing at engine startup, that doesn't cause any thermal shock and damage those engines.
Stage 1 RPO unload is complete.
So with that call, we now have 2 of the 4 tanks on the Falcon 9 rocket full. Both kerosene tanks on the first and second stages are at their flight levels. The kerosene is a rocket-grade kerosene called RP1. It's highly refined and provides the fuel that is burned along with the liquid oxygen oxidizer. Everything continuing to look good as we reach the T-minus 5-minute mark. Soon be starting the strong back retraction process.
Falcon 9 tanks are pressurizing for strong back retract.
That call indicates that the tanks will be pressurized to make the rocket a little more rigid before the support of the strong back is withdrawn.
Strong back retract has started.
The retract sequence begins with the opening of the clamp arms around the second stage. We'll hopefully see a close-up of that. And there we can see those clamp arms opening up.
LD, this is NLM on Countdown Net.
LD?
Yes, LD, NASA is go for the Sentinel 6B launch.
Copy all. Good news.
NASA's Tim Dunn giving the SpaceX launch director the go of the NASA team. T-minus 3 minutes. The rocket's autonomous destruct system will be armed shortly.
Stage 1 LOX load is complete.
And loading of liquid oxygen on the first stage is now complete. Less than 2.5 minutes to launch. Falcon 9 will be switching to internal power. The thrust vector control system is being tested on the second stage.
Stage 2 LOX load is complete.
And with that call, the Falcon 9 is now fully loaded with 1 million pounds of propellants. We're going to soon see some venting as SpaceX purges the Launchpad propellant lines.
Ground gas closeouts.
And there we can hear the launch team confirming those ground gas closeouts are underway. You can see that in the form of the venting. We're approaching the final minute of the countdown, where the onboard computers will take control and the 2 stages will be pressurized for flight. The onboard computer will perform checks at the first stage steering system.
Falcon 9 is in startup.
We have confirmation that the onboard computers have control of the countdown. Let's listen in for the launch director's final go for launch.
LD is go for launch.
And there we have it. The Falcon 9 is cleared for launch. Let's listen in to the final seconds of the countdown.
T-minus 3 seconds. T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff of Falcon 9. Go SpaceX, go Sentinel 6B.
Vehicle is pitching downrange.
Stage 1 propulsion is nominal.
The Falcon 9 is pitched downrange,
Falcon
heading
9
in a
power
southeasterly
telemetry or
trajectory.
nominal?
Everything looking good. 50 seconds into flight. The Merlin engine should be throttling down as the vehicle approaches max Q.
Falcon 9 is supersonic. Max Q.
Falcon 9 is traveling faster than the speed of sound and is
back chilled.
experiencing maximum aerodynamic pressure. The second stage engine is being chilled prior to its ignition. Approaching main engine cutoff, or MECO.
Main engine cutoff.
Stage separation confirmed.
MVAC ignition. Stage 1 Boostback startup.
Coming up on payload fairing separation.
Fairing separation confirmed.
There we see the payload fairings just passing the engine nozzles and a view of the Sentinel 6B satellite now exposed. the payload fairings having done their job and protecting it during the climb through the thicker layers of the atmosphere.
Stage 1 boostback shutdown.
We have confirmation of the shutdown of the boostback burn that will have reversed the direction of the first stage. It's still climbing in altitude, but reversing its course to return to Vandenberg. Next up will be the entry burn. This is a crucial burn that protects the Falcon 9 first stage from the heat of re-entry as it plunges back into the atmosphere. Currently, that first stage is still climbing at an altitude of 162 kilometers. The Falcon 9 first stage has reached its apogee and is now starting to fall back to Earth. We've not seen any views of that first stage recently. You can see in the bottom left-hand corner the speed gauge and altitude of the first stage. The second stage speed and altitude on the right-hand side of the screen. The first stage is picking up speed and will perform that entry burn to slam on the brakes and slow it down, so it survives as it heats up as it re-enters the atmosphere. Hopefully we will see some views from the first stage shortly. The first stage is returning to landing zone 4 at Vandenberg. Residents along the coast of California may hear sonic booms as the rocket descends. It's now passed under the Kármán line. Coming up on that entry burn, let's watch for the speed to dramatically drop.
Stage 1 entry burn startup.
That entry burn starts with one engine, and then two more are ignited.
Stage 2 is in terminal guidance.
And see that burn taking place from the onboard camera on the first stage.
Stage 1 entry burn shutdown.
And that maneuver is now complete, and we can see the speed is
Stage 2 FTS
dropped
saved.
somewhat. Returning to views of the Merlin vacuum engine.
MVAC shutdown.
That's
Nominal
completed
orbit
its first
insertion.
one.
Stage 1 transonic.
Stage 1 FTS is safe.
Good orbit
Stage
for the
1
second
landing
stage.
burn.
The landing burn is underway. We're not seeing any video from SpaceX, so here we go.
Stage 1 landing confirmed.
A little hard to see in the dark there, but booster 1097 back on the ground, just a short distance from where it took off. That was the successful completion of the 500th reuse of a Falcon 9 booster. So the Falcon 9 second stage is in a 44-minute coast before the Merlin vacuum engine is ignited for a second time on this mission. That burn coming up in about 41 minutes from now. You can see the onboard cameras showing the Sentinel-6B satellite top that second stage. It's heading for an orbit about 800 miles high. From that vantage point, inclined at 66 degrees to the equator, it will be able to take measurements with its sophisticated radar equipment that cover about 95% of the ice-free oceans of the world. Its measurements are accurate to about 3 centimeters, which is about an inch. We're looking again into NASA's Mission Directors Center. Returning to SpaceX's orbital tracking map, showing the second stage in its parking orbit. Currently in an orbit of 201 kilometers. That's about 125 miles. We're 16 minutes and 25 seconds into the flight of this Falcon 9 rocket, carrying the Sentinel 6B ocean monitoring satellite for NASA, NOAA, the European Space Agency, the European Commission, and EUMETSAT. It's truly an international endeavor to continue the monitoring of ocean heights. This has been an effort that has continued over many decades from space. The data from these missions is crucial for improving the accuracy of weather forecasts and also keeping tabs on the continuing rise in global ocean levels, which are believed by scientists to be caused by climate change. There's about 32 minutes left in this coast phase for the Falcon 9 second stage. It's a short 10-second burn coming up at the T plus 52 minute and 2-second mark. Once that burn is complete, the Sentinel 6B will be deployed from the payload adapter on the top of the second stage. That deployment should occur 57 minutes and 13 seconds into flight. We'll stay on the air until the completion of the mission. So here's an artist's impression of what the deployment of the Sentinel 6B satellite will look like from the European Space Agency. This artist concept showing the second stage with the black payload adapter that we saw earlier in the encapsulation video. The ring holding the Sentinel 6B to that payload adapter will be released, and the satellite will gently drift away and will be under the watchful eye of the controllers that we saw earlier in the broadcast at the European Space Operations Center, ESOC, in Darmstadt, Germany. The main instrument on the Sentinel 6B and its predecessor, Sentinel 6 Michael Freilich, is the Poseidon 4 radar altimeter, which was developed by ESA. There's also a second microwave radiometer provided by NASA on the spacecraft. The NASA instrument determines how much water content is in the atmosphere, and that improves the accuracy of the radar instrument on the satellite. The second stage is now approaching the tip of South America, passing over Chile and Argentina. I'm going to waffle on more about the Let's continue to look at the steps that lie ahead for the Sentinel-6B satellite once it is deployed from the Falcon 9 second stage. That's coming up in approximately 37 minutes from now, 28 minutes from now. As we said earlier, it's going to be controlled from the European Space Agency's tracking and command facility at Darmstadt in Germany. The initial checkout of the satellite is known as the launch and early orbit phase. And it's during this time that the various systems will be activated and any potential problems will be identified. But assuming all is going well during the first few days of the mission, there will be 2 critical maneuvers that will raise the spacecraft towards its operational orbit. That will all be controlled from the European Space Operations Center, ESOC, in Darmstadt. But 3 days into the mission, the command and control of the satellite will be moved to EUMETSAT, the European Weather Forecasting Organization. It will take some time for the spacecraft to drift towards its final orbit. The orbit is about 1,300 kilometers in altitude, about 800 miles high. The Sentinel-6B satellite will take over from the Sentinel-6 Michael Freilich twin satellite that was launched back in November 2020, almost exactly 5 years ago. We're looking back into NASA's Mission Directors Center. Couple of questions in the chat about how we're bringing you this broadcast. We're broadcasting from our news bureau at NASA's Kennedy Space Center press site. And we're receiving our video feeds courtesy of NASA. Does give us a little bit of a head start in getting these pictures to you before you can actually see them on the official NASA broadcast on YouTube. You can see that the second stage has now passed over the tip of South America, heading out across the South Atlantic. There's about 17 minutes left before the firing of the second stage, a 10-second burn. So while we wait for that, just dipping into the chat, give a big thank you to Virginia Pruitt for a $10 super chat. And I am Lita, who offered a $5 super chat and is wishing Will a good vacation, says he deserves it, and thanking the Spaceflight Now team. We really appreciate that. I am Lita. Taking a look back into the ESOC Control Center in Darmstadt. We're about 13 minutes away from the next burn. I want to give a big thank you to our moderators in the chat. Jeff Hansen and Astro Joe, I see are in there keeping the chat kosher, as Will would like to say. Also, a big thank you to Cumulus Granatus for answering people's questions. T plus 41 minutes and 35 seconds. And the second stage continues its trek across the South Atlantic. We're now about 10 minutes from the reignition of the Merlin vacuum engine on the second stage. T plus 45 minutes and counting. The Falcon 9 second stage continuing to cross the southern Atlantic Ocean. Looks like it will be passing into the Indian Ocean close to the island of Madagascar. SpaceX has a ground station in South Africa, but it's not clear if we will get views from the rocket. It's parsing quite south and east of South Africa, maybe out of range. there we go. Beautiful view from the upper stage camera, looking at the Sentinel 6B satellite and the Earth below. We're about 4 minutes away from the burn of the second stage. It's a short burn, 10 or 11 seconds. SpaceX says 10, NASA says 11, so perhaps somewhere in the middle. Chill down of that Merlin engine is underway. Just lost the live views. Hopefully we will get those back. But that chill down process will ensure there's no thermal shock. About 2.5 minutes away from the burn of the Merlin vacuum engine. There we see the chill down process continuing. We haven't heard any calls from the SpaceX team recently, but hopefully we will start to hear some. This burn is known as SES-2 for second engine start 2. Now less than a minute away from that burn. This burn will be between 10 and 11 seconds in length. The spacecraft is approaching its apogee, and That will be the point at which the engine fires to circularize the orbit.
MVAC startup.
There we see the ignition, piece of ice being blown away in that.
And MVAC shutdown.
And there's the conclusion of the burn, SECO 2, second engine cutoff.
Nominal orbit insertion.
SpaceX flight controllers confirming a nominal orbit. That burn should have helped circularize the orbit at about 1,300 kilometers in altitude, or 800 miles. We're about 4 minutes away from the deployment of the Sentinel-6B satellite. Could be about 35 minutes before ground controllers acquire a signal from the spacecraft. Less than 2 minutes now to the deployment of the Sentinel-6B. You can see Madagascar down below. The second stage is parsing between the island of Madagascar and Mauritius. You can just make out Madagascar to the left of the spacecraft and the coast of Africa. Now less than a minute to deploy.
Sentinel 6B, deploy confirmed.
Fantastic video as the Sentinel 6B drifts away from the upper stage of the Falcon 9. Begin its mission monitoring the world's oceans, specifically the sea heights. Its cloud-piercing radar is capable of measuring sea heights to an accuracy of about 3 centimeters or about 1 inch. You can see that ring that held the satellite to the payload adapter at the moment of separation that popped open, releasing the spacecraft. You can also see Madagascar below. Now looking inside the European Space Agency's ESOC control room, where they will be supervising the first 3 days of the spacecraft's on-orbit checkout. They'll be conducting some maneuvers to raise the orbit, reach the precise orbit needed for this mission. We do. We're just waiting to see if NASA is going to speak to any of the NASA officials here. A beautiful view of the Merlin vacuum engine with the sun shining bright behind it. We'll stay with these views as long as we get them from NASA and SpaceX. The Falcon 9 second stage will perform a deorbit burn shortly to remove it from orbit. It will burn up in the atmosphere. That will ensure that it does not become an orbital debris problem. Well, it looks like we're going to take a quick replay from NASA of the liftoff.
7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff of Falcon 9. Go SpaceX, go Sentinel 6B.
Sentinel 6B rising, extending nearly 4 decades of the precise sea level record from space.
Falcon 9 booster is currently firing.
So let's conclude our coverage with a quick look at the mission stats. This was the third flight for Falcon 9 booster 1097 and the 500th reuse of a Falcon 9 booster. The 564th Falcon 9 launch to date. The 147th Falcon 9 mission of 2025. It's the 169th SpaceX Orbital launch in the last 365 days. SpaceX losing a little bit of ground on that statistic. They did get to 170th launch in 365 days, but have slid a little bit. They were hoping to reach 170 in total for the calendar year, but they certainly reached that number in terms of the rolling 365-day figure. This was the 162nd SpaceX Orbital launch from Slick 4 East, and the 230th overall orbital launch from that pad. Taking a look at the bar chart, you can see that SpaceX has topped its calendar year record set just last year. It's well ahead now. You can really see the acceleration in the launch cadence that has occurred over the last 4 years. So with that, I just want to thank my colleague, John Pisani, for managing the technical side of tonight's broadcast. Big thank you to our mods in the chat, and to Cumulus Granatus for answering viewers' questions. And a big thank you to all of you for tuning in to our coverage of this launch from Vandenberg Space Force Base. Our next launch is from Cape Canaveral on Tuesday. So until then, wish you a very good night, and we'll see you next time.